Today we're going to continue working on creating equations and using equations to complete tables. Okay, so we'll be working through real-world problems and again using the equations we come up from those to complete tables. Okay, the first example I'll do for you guys on my screen is how we can create this table of values using the equation p equals m plus 9. In each of the tables we work on, we'll have a label indicating which value is which. So this is my M column and this is the P column. To solve for the empty boxes in my table, I'm going to need to substitute the value in on the other side into the equation. So this 6 in this first one is representing the M value. So to solve for the P value, I'm going to put 6 in place of the m and evaluate that expression. So 6 plus 9 means this p would be 15. Following that same process, okay, the next one I want to know if 36 is m, what does p equal? Okay, so I'm again replacing my m value here with 36. So I add these two together, p would equal 45. In the next empty box, I'm going to identify the m value when p is 75. So this 75 is going where the p is, and I need to solve this equation for m. To identify the value of m, I'm actually going to use my inverse operation to solve. If I complete that, 75 minus 9 is 64. Okay, so when I'm going from my dependent variable to my independent, I'm using the inverse operation to solve. In this next example, I'm going to come up with an equation for this real-world situation. Okay, in the problems we're working on to begin with, we are going to be told what the two variables are. And then we're going to have to decide to start which is dependent, which is independent. Okay, our dependent variable will be controlled by our independent. So when I'm deciding which one is which, I'm going to read this back to myself. Okay, so does the number of stickers each person gets, does that depend on how many stickers she's going to share in total? Or is the number of stickers she shares in total dependent on how many each person gets? If you read those out loud to yourself, it will be that the number that each person gets, which we're going to use an F for, is dependent on how many stickers she has in total. Also in this problem, we should be able to identify a keyword or phrase to help us decide what operation. When we're sharing something and we're sharing it into groups, that indicates that we have division. When I go to write my equation, okay, we're going to start by writing the dependent variable. So in this problem, that is f. Since the dependent variable is determined by the independent, we leave that on one side of the equation by itself. Okay, in this problem, we're using division. So before I include my independent variable with the operation division, I want to think about the order in which I should write those. Okay, because division is not commutative, we have to make sure we put these in the right order. So S, my independent variable, represents how many total stickers I have, which is what I would be splitting up. So I'm going to take my stickers and I'm going to divide them into groups. And what I'm dividing them into is back up here in the information. I'm dividing it between 4 people. Okay, so when you write your equation, you should have both your independent and dependent variables, but they're not both together. So they should be on opposite sides of the equation. All right, my last example is going to be combining both of these concepts together. So I'm going to come up with an equation and then I'm going to use it to complete a table. Ben is collecting bugs for a science project. He has 12 bugs already. The equation that we're going to write is going to be for the total number of bugs if he collects B more. So, which one is controlling the other? Typically, if we're calculating a total, the total will be the dependent variable. So the total number of bugs he has for his project is dependent on B, how many more bugs he gets. Okay. When I'm identifying the operation, again, I want to try to find a keyword or break the problem down. In this one, I would say my keyword here is more, and more would mean adding. The equation, again, starts with what is my dependent, so T, the total number, by itself. Okay, and because this one is adding, the order won't matter, so I can put it as B plus the 12 that I start with, or I can write this as 12 plus B. Okay, so either order would be okay because in addition it's commutative and the order does not matter. Now that I've come up with that equation, I should be able to use it to complete this table. Remember, when we're completing the table, we're using substitution, so I'm replacing one of the variables to tell me the other. When you look up here, okay, be careful to pay attention to which one this represents. So 18 represents the number of bugs collected, so I'm going to put that there for the B. And so I'm calculating the total by replacing B with 18 and adding 12. And my next set of numbers in the table, 42, represents the total. Okay, so that's going to be written in place of the T. So 42 equals something plus 12. Okay, and so I want to know what this B equals for bugs collected. So I would subtract from both sides, and here B is 30. Last one, okay, looking up above, 23 is going to be replaced with the B, so total is equal to 23 plus 12, which will give me 45. As you continue working on these problems, take your time, read and annotate the word problem. So underlining and circling will help you distinguish and break it up to create the equation. Okay, this is a skill that we're going to continue working on next week in class, so please have some patience. And the more you try, the more feedback I can give you.